as much space near the aisles as possible. That'd be much appreciated for the people who come in late. Thank you. People up the back, if you found yourself standing and looking for a seat, there's a whole bunch of them over on the far side here. So if you're looking for a seat, over this side. Ladies and gentlemen, if you could please find a seat. We're about to make a start here. About to make a start. Great. Okay, welcome to this third session of PyCon 2014 here in Montreal. Our next presenter is a software engineer from Rackspace, but you probably know him from his contributions to CPython, PyPy, and Django, and for his work on the board of the Python Software Foundation. He's here to talk to us about Pickles and how they're for delis and not software. Please welcome Alex Gaynor.
Hi, everybody. Thanks for coming. Like Chris said, I'm here to talk about Pickles and their role in delis. Also, like Chris said, I write a lot of open source software. I serve on the board of the Python Software Foundation, and I work at Rackspace. I'm very passionate about all those things, but I'm not here to talk about any of them. Come find me in the halls, ask me about those if you're interested. So, this talk covers a few of my favorite things. For example, delis. If you'd like to come find me later and talk about delis, we can talk about Schwartz's, smoked meat, and many other wonderful things in Montreal. I'm also a big fan of pickles, dill pickles, and I'm a fan of software to varying degrees. This talk is also about a few of my least favorite things, such as software and the Pickle module. Some of you might be familiar with it. For those of you who aren't, what is Pickle? Pickle is a serialization library in Python. It's part of the Python standard library. And you can sort of hand it any old random Python object, and it will turn it into bytes. And then later, at your convenience, you can take those bytes, and in theory, you can get your object back just as you gave it to it in the first place. There's a couple major use cases for this. For example, you might have two Python processes running at the same time, and you want to send stuff between them. So this is exactly what the standard library multiprocessing module does. It creates a pipe between the two processes, pickles things, and sends them across it. You might also use it for storing random Python objects in your database. For example, if you were here in the session right before me about memcached, you might have heard about how Python objects with most of the standard memcached libraries for Python will pickle them, so you can store basically whatever objects you like in your memcached instance. It sounds pretty cool. We can all sort of see the appeal of being able to store, persist, and then get back our objects later in some different Python process, perhaps days later. But how does it work? So if we look at the dumps function, we can see that we pass it a list containing the number 1, the letter A, and none. We get some stuff back out. We get random nonsense, right? This is unintelligible nonsense. We can see the letter A in there, I guess, but that's pretty much the extent of us being able to understand this. So we might go to the standard lib, and we might start poking around in pickle.py to see what's up. And this code has been edited a little for readability and to fit on a slide. But dump is pretty simple. The first thing it does is it gets the type of the object we tried to dump. And it's got a little dispatch table where it's got dump functions for a bunch of built-in types. So we try to get the dump function out of our dispatch table. And if there was something there, we call it, and then we're done. So we might see what's in that dispatch table for list, and we'd see a function a little bit like this. So the first thing it does is it writes this marker, empty list, whatever that is. And then we iterate over the list, as we might have expected, and we dump everything in there, and then we write append. So what's going on? Pickle is a protocol where basically what happens is first you write out a type specifier saying, hey, this is what's coming, this is what's next. So we start by creating an empty list, and then we dump each item in the list and append it somehow to the list we just created. So since we're clearly recursing, we have to see then how we dump ints, how we dump strings, how we dump none to see where each of those come from. Dump int is a bit similar. We write our int specifier saying, hey, an int is coming. Then we write out the string representation of our int, and then we have a new line to indicate we're done. None is even easier. None has no data associated with it. It's just a magic none marker, just this type specifier. The standard lib, for our convenience, has a module called Pickle Tools, which is unfortunately very underknown, but which contains some useful tools for understanding the secrets of what this means and visualizing them for us. Again, I've edited the output a little bit so it'll fit on the slide, but as you can see, If we try to disassemble this same random nonsense we started with, we get a list. The first thing we get is a list. Then we see our int instruction, and the argument is on the right-hand side, so that int has an argument of 1. Then we append it. We have our string a, and we append it. We have our none, and we append it. And then we end with this stop code. And stop basically says, hey, we're done. Whatever you are dealing with, that's the result of unpickling. So stop lets pickle be self-delimiting. The pickle protocol can know when it's done. So those are some built-in types, and Pickle is a table that lets us look up how to serialize built-in types. What about types we create? We write classes all the time. They have behaviors. They have data. How do we serialize those? We said in the beginning we wanted to serialize arbitrary classes. So what happens? So what if it's not in dispatch? It turns out there's actually there's a behavior where if it's not in dispatch, we call this under-reduce method. And there's actually two versions of under-reduce. There's under-reduce and under-reduce x. We're just going to look at the simplified form. So we call under-reduce, and it's supposed to return a function and some arguments. And so then we go about, we save this function, we save these arguments, and then we write this reduce code. So what's this look like? So say we just created an object. Boring, plain old, built-in object, nothing special about it. What does this look like dumped? So the first thing we see is this global code, and it's got an argument of copy reg under reconstructor, whatever that is. Then we've got another one of these globals with under built-in object, none, tuple, reduce, stop. What's going on here? So the first thing we have is the name of the reconstructor function. This is the function you return from under reduce that says, how do I go about, what function do I call when I need to create this object again? And global references a module name and the function within that module. So the Python standard lib includes a module named copyreg with a function named under reconstructor, and this will be called to create it. The next item we have is the type. So just like what we created, we have an instance of under built-in object. And then the arguments to create it are none. We create a tuple out of it. And then we call this reduce thing, and we're done. That's the end. So let's say we create a class, x. Its constructor creates some really cool attribute. It's got a value of 3, and we create an instance of it. What does the disassembly of this look like? So yet again, we have this global copyreg reconstructor thing. Now it's got, instead of just under built-in object, it's got under main x, the name of our class. So we have to know which class we want to create instances of. And then we also store all of its parents. So under built-in object is still also stored there. We do that, and then you can see we have this dict thing. We create a dict, and we put the string myCoolAddr, we put the integer 3, and then we do a set item on that dict, basically saying at the key myCoolAddr, store the value 3. Then we use this new build operation to actually create the instance of our class, and then we return it. So that's good so far. That's if we just have some really simple attributes. We can see if we tried even more attributes, we would see basically the behavior of this is store everything in under dict in the pickle, and then reconstruct by setting those same attributes back on the object. What if we want some more custom logic? What if, for example, we have something that can't be pickled? For example, pickle can't store a file object because this is this ephemeral reference that's only applicable within your process. You wouldn't be able to unpickle a reference to a file if the name of the file was something specific to your machine and then it didn't exist on another computer. That would kind of defeat the point of Pickle's ability to restore anything it was able to make a pickle for. And if we have an object that has a file for an attribute and we want to pickle it, we're going to need something. So we have this under reduce method. We know it's got some default behavior of storing everything in, that's in under dict. What if we want to define it ourselves? What's it look like? So in this case, we can see it returns a tuple that contains 2 items. The first item is this reconstructor function. In this case, I'm using stir. The second item in the tuple is yet another tuple which contains all the arguments we want to call our reconstructor function with. So if we try to round trip an instance of this, we will see that dumping and then loading a funky pickle actually results in the string ABC, which we got by calling stir with ABC. It's a bit of a bizarre behavior, but perhaps we might want to leverage this to do things either to construct with different arguments, to call some specific function that maybe has different behavior. Okay, so now we've sort of seen how we pickle things and what we get out of Pickle. We want to load stuff from Pickle. What does that look like? Pickle is a stack machine. And if you've ever looked at CPython's internals or the dis module, you might have seen a bit of what this looks like. Let's say we've got this object. Again, 1, A, none. A stack machine essentially means that we have two arrays inside Pickle. We have the array of all the instructions, basically. Pickle is a set of instructions, which makes it a bit different from other serialization formats. Other serialization formats, if you ever looked at JSON or BSON, MessagePack, anything like this is very data-oriented. Pickle is instruction-oriented. And so we have a set of instructions, and then we have a stack where we can push items to the top and pop items from the top of the stack. If you ever worked with a reverse Polish notation calculator, it's exactly the same idea. You put your data, and then you say what you want to do with it. So the first instruction we have is list. What does list do? It pushes an empty list to the top. Then we have this int instruction with the number 1. It will then push the number 1 to the top. So now our stack has two items, an empty list and the number 1. What do? Append will then take the top item, the number 1, and remove it. And then it will append it back to the list. So now we have one item on our stack, which is just a list with the number 1 in it. We have our string A. It pushes that to the top of the stack. And then we append it back to our list. We push none back onto the stack, and then we append it. So now we have all of our items. Now stop comes the end and says, hey, I've got one thing left on my stack. We're done. We were called, we had one item, there's one thing left, we're done. What does this all look like? It's all actually kind of shockingly simple. This is the entire core of the Pickle logic. While true, we read one item from our stream. That's the type signifier we looked at earlier. And then we have another dispatch table. We dispatch on this key, we call this function, and then we just keep going until we receive a stop exception, and that will contain the value. So what does this look like in practice? For lists, we push, as you might expect, an empty list. All we do is stack is just itself another list. So all this empty list instruction does is append a list to the end of this array. Our append opcode gets the stack, and it pops the value off, and then it gets the list and appends the item to the list. So empty list adds one item to our stack, append removes one item from our stack. What about the reduce instruction we saw earlier for dealing with arbitrary objects? Well, it pops the arguments off the stack, and then it reads the function, calls the function, and replaces the value of the function with whatever we got from calling our function. Now, you might be thinking to yourself, a pickle can contain a reference to an arbitrary function, and then we'll call whatever function you choose. What happens? So this is some pretty serious security implications. So for example, what if we had an under-reduce method that returned, say, lister with a string, with the dot? So so we dump this, we get a pickle, nothing exciting happens then. When we try to load it, however, now it's going to get all the items in our directory, and that's going to be the result of this. This is not a purely hypothetical attack. This has been a security flaw that's happened to a number of applications where they unserialize untrusted objects. Pickle cannot safely accept data that you do not trust. Lister seems kind of harmless. What if we called something even more exciting? Exec, os.system. Essentially, if you unpickle an arbitrary object, you are letting it whoever provided that object, do whatever they want with your system. So it better be somebody you trust. This is why the Pickle documentation begins with a big red warning saying, hey, you don't want to use this if you don't trust your data. And I highly recommend this write-up of one of the more high-profile security vulnerabilities as a result of using Pickle. It sort of dives into how you can really seriously weaponize this to let an attacker get an arbitrary shell on your computer. So that's security. Are there any other problems with Pickle, though? If we always trust our data, let's say we're putting it in our own database, and we're only reading out of our own database, is Pickle still appropriate? This is a quote I really love from something called the E-programming language. Do you, programmer, take this object to be part of the persistent state of your application, to have and to hold through maintenance and iterations for past and future versions as long as the application shall live? So I've got a story. Our story begins many, many maintenance iterations ago in a code base far, far away. And somebody put a pickle into a database. As I've said, pickles are really only appropriate on a plate next to a nice sandwich, some Russian dressing, good rye bread. Nonetheless, somebody put a pickle in the database. And it sat there for about 18 months. Nobody touched this row in the database. It was some unexciting archive. And then I went to do a migration on this table. We wanted to optimize how some of the other fields were stored. As a part of this migration, I looked at this field. Just sort of poked at it, didn't even make any changes. We run this over, it's like a 1.6 million row table. We start running this migration. Like halfway through, 800,000 rows in, I get this obscure exception. Module has no attribute. What? It turns out that, as we saw, one of the things Pickle stores is the name of your class. What if that class ceases to exist, as this class had in the 18 months since somebody had written to the database? So we can sort of see this here. We create our class X, we make an instance of it, we dump our pickle. Then X goes away, say because 18 months had come to pass and no one had been thinking about this table as they were trying to ship a product. We try to load our pickle. Module has no attribute X. We can't find our class. In our case, we were lucky enough to simply be able to go back and get and restore the class, copy and paste it out of history, load these pickles, and then delete them because they were clearly useless at this point. But what if we have a slightly more interesting case? We have a new class. It's got an instance attribute X. Its value is 4. It's got a function f that just returns the value of x. So we dump it. We load it up again. We can see we've got an instance of x. It's not very exciting. Then some maintenance happens to our code base. Something changes. Now x becomes known as y. We still construct it with the value 4. F now returns the value of y. We try to load our pickle, and suddenly x has no attribute y. Well, we had no idea. We were making changes to our class, and someone somewhere was storing a pickle that was seriously deeply concerned with the internal attributes, as we saw. The default behavior when pickling is to return everything in under_dict, and now the stuff we expect to be in under_dict is different. This is, in my opinion, the most serious flaw with Pickle, the maintainability aspect. The fact that Pickle ties you to whatever the representation was at the time you pickled it, by default. You can create an under_reduce that does something more clever. That involves writing some software. And in my opinion, if you're going to write some software, it's ideal not to use it in the context of a system that also comes with some other issues. So I'm going to advocate for a different approach, which I like to think of as calling some functions with some arguments, which is another thing I'm deeply passionate about. So we have a table. I work for a table manufacturer, and we have tables, and they're all squares, because squares are an appropriate shape for tables to be in. And sometimes I like to serialize my tables and ship them places. And so I have a dump method. I wrote a dump method, and it pretty simply just dumps this dict. It has a version and a size. The size is pretty self-explanatory. It's the same as our attribute. Version is a little new. Basically, the idea of the version is this is going to change. We know it's going to change. We just saw what happens when it changes, and you don't have any way to correct for it. So we need to write down what's going on. Then we want to load it. So we have a pretty simple load method. We check to make sure the version is what we expect. In the real world, we might raise a useful exception, but this is not the real world. These are slides. And then we create an instance of our class with the size. Time passes, and my company gets out of the business of making square tables. We're now into rectangles. Rectangles are popular. Rectangles do not just have a size. They have a height, and they have a width. So we change our dump method. Now we're dumping the height and the width. That makes sense. We've incremented the version because we've changed the representation of our tables. Something has changed. Therefore, we need a way to signify to our load method, which now looks a bit like this. We can still handle things where the version is 1 because we can compute their height and our width from our size. But we can also handle our new case transparently without expecting the user to change their application or to change the stored data. We can handle either format now, and of course we can continue adding more versions for as long as necessary. What are the advantages? It's more testable. Because we control both our dump and our load methods, we can make assertions about what we expect, and because our dump method is not so opaque to us, where Pickle returns stuff we can maybe understand with the help of a Pickles tools module and some documentation and a little bit of source code reading, but if we control the dump, we can make strong assertions about it. For example, what if the standard library changed how something dumped a pickle? It would be hard to update our tests for this because we wouldn't really know about it because that code is not in our control. It's also simpler. It turns out with under-reduce and a couple of other special methods, Pickle really does give us all the tools to do the same thing. Unfortunately, I think it's frankly a lot more code to write it inside somebody else's framework than it is to write it inside of our own. And lastly, it's more auditable in the sense that we can more easily look over our code because we've forced ourselves to version everything from the start. One of the things that happens when you pickle an object is it will recursively pickle everything in under-dict. So even if you are careful and studious and you write correct under-reduce and other methods on your top-level object, if it has some attribute that doesn't pickle correctly, that will silently later blow up in your face because Pickle can handle everything practically by default, whereas this will only handle classes and objects we write our own logic for, which makes it much easier for us to verify that really everything has these properties that we're looking for, where they round trip nicely and they don't have the security issues and everything else. I use JSON in these examples, but there's a couple of other things you might want to look at. If you've ever used Pickle, one of the things it lets you do is it lets you set a protocol which basically controls how fast it goes, and to a lesser extent how readable it is. JSON, like the default Pickle protocol, is a text-based protocol, and JSON happens to be incredibly readable, widely supported, like every language on the planet supports JSON. So if that's appealing, you might want to use JSON. MessagePack, by contrast, is a binary format, so it's slightly less easy to read. It's also fairly well supported across many languages, although probably not as widely as JSON. And it's much faster as a result of being a binary protocol and having very, very fast implementations. Pickle is unsafe at any speed. You cannot provide untrusted objects to Pickle, or you will expose yourself to serious security risks. You can work around these by verifying that you only ever deal with trusted Pickles, but it requires you to be incredibly diligent and make sure you never mess up even once. It has maintainability issues regardless of what objects you pass it, even if you only provide trusted objects. Unless you also write a whole bunch of code, you will not be able to guarantee that you round trip unless your code never changes. On the other hand, Pickles are great at Delis. Thank you, and questions?
So if you have questions, please line up at the microphone in the middle here. We've got quite a bit of time for that, so if you have anything to ask Alex, just line up and ask him. First question, go ahead.
Hello, Alex. Thank you for your intense thoughts on this matter. Obviously, Pickle is increasingly important to a huge audience as we turn to looking for solutions for asynchrony and multi-tenancy. I'm wondering what you think about sessions. That seems like one maybe place where pickling may still make sense, not necessarily in the cookie backend, which I know is already sort of objectionable. But if you're having to pass objects through a session, like with the Django Sessions framework, do you think that it is practical to sort of like stop and create your dump and load methodology for each individual object, or is there some wiggle room where perhaps Pickle is still okay using one of the non-cookie backend for the Django Sessions framework, or sort of what's your vision there for the way sessions will work in a Pickle-free world?
Sure, so that's a great question. Session is, of course, one of the great places where it's really appealing to use Pickle, because it just means you can put whatever in your session and you'll be able to get it back out later. It also happens to be one of the places where I've run into these maintainability issues, perhaps more frequently than anywhere else. And one of the big issues I have with putting Pickles in sessions, and it's actually safe to use even in the cookie session if you use a signed cookie, is I've used a signed cookie, so I've been able to verify that I really trust the data. And I put this Pickle out there. I don't know how long, I don't know how old cookies are going to be lying around for, and so I will see objects that I thought were gone long ago pop back. And so it generates huge maintenance headaches. It's actually probably the biggest source of these maintenance headaches. I really strongly believe that either just using these dump methods directly or only attempting to store really simple objects that natively support, that the JSON module can natively dump, I really think that's strongly preferable even in sessions.
I agree with most of your objections, but what about under get state and under set state? It is possible to migrate Pickles across class changes by writing custom get state and set state methods. I've
Sure.
done it, it works.
Yeah, you can totally write under gets and set state methods, which will let you do this sort of versioning and handle these sort of upgrades and deal with all these what I call legacy pickles. The problem I run into is Pickle is unsafe by default, and you can make it safe by writing a bunch of code. I think it's much easier to start from an approach of, hey, we can serialize nothing, and build up from there. That way you don't run into cases where you accidentally made a mistake in the past and now have to deal with what is the migration logic when you forgot to include a version field. By forcing yourself to think about these things, you're more likely to handle it correctly from the beginning.
It seems like the most obvious security vulnerability in Pickle is from accepting an arbitrary callable to create a class.
Yeah.
So is that security vulnerability inherent in what Pickle does in creating or in serializing arbitrary Python objects? Or would it be possible to, I guess, fix or change Pickle or design a new Pickle that serializes arbitrary objects but doesn't have these security vulnerabilities?
I can imagine putting a series of restrictions on it that make it possible to make it more secure. For example, forcing you to manually specify which functions are safe to call as loaders, and somehow like registering these as, hey, this is a safe function, Pickle may call this, and blacklisting everything that's not on that list. I can imagine a series of restrictions that work like that. I think the problem you run into then is it's, in many respects, a desirable property for a lot of people that Pickle is so automatic that you can just dump arbitrary objects. Like I said, it's so appealing. You can just put anything in your session and you'll get it back later. As you put more and more caveats and restrictions about what you can do, I think it loses a lot of that luster.
Is the Pickle stack machine Turing complete?
I think probably yes, but I haven't proved it. I mean, certainly you can call arbitrary functions, right?
Yeah. But I mean, can you just have plain old Pickle opcodes which could like make an infinite loop or something?
I don't know. I would have to think about it. Sorry.
Hi, can you recommend a serializer that actually handles cyclic references?
Yeah, so cyclic references are one of the major issues. Pickle handles them, JSON doesn't. I think YAML does, although one warning I have about YAML is Python standard library, or not standard library, the most common YAML implementation has a load method and a safe load method. You definitely want the safe version. I believe YAML handles circular references. I'm not really aware of another popular serialization that does. The standard lib Marshall, which has many related issues to Pickle.
Yeah.
Marshall is what's used to create the
I'm not
.pyc
going to use
files.
Marshall.
Yeah.
Okay, because I've been looking for a long time for a library that does handle cyclic references, and I'm still using Pickle because I haven't found one.
Yeah, cyclic references are definitely one of the places where one of the things that make Pickle look nice.
Hi. Is MessagePack faster than Pickle?
I've never sat down to benchmark it, but I would think so.
Even the Pickle Protocol 2, which is...
I believe so.
Yeah. And how easy is it to use MessagePack as a drop-in replacement for Pickle?
The MessagePack module looks basically like the JSON and Pickle modules. You have a dump function, you have a load function. MessagePack is basically a binary form of JSON in that you don't need some external file like you need with a system like Thrift or protobufs if you use those. It includes all the information in the dumped MessagePack that you need to load it up. And it supports, I think every type JSON supports and probably a few more.
So it is faster?
I believe so, yeah.
Thank you.
Sorry for sniffling. I was just really moved by that those wedding vows from the E mailing list. So E doesn't have the dynamic reflection that's required to implement JSON, YAML, MessagePack, etc., serializers and deserializers that most of us have come to know and love when doing Python and not using Pickle. Are there any lessons from that family of languages that are useful for working with serializers? Because obviously, you know, the Pickle lesson is don't pickle, but is there anything specific that the next person who invents their own serialization format could learn from?
I think the biggest thing to learn from all of these families is the sort of the set of issues you have to be conscious about. And frankly, the possibility that one serialization format doesn't fit all use cases is probably the biggest lesson I take away from these things.
Cool, thank you.
Are there issues with Pickle for distribution where you're running a Pickle that's trusted and only running on one version of the code?
So there's a possibility it's running on one version of your code, but multiple versions of Python, where you run into, if you serialize something with a newer version of Python using one of the higher Pickle protocols, it uses a feature or a protocol that doesn't exist in the older Pickle. But if you really have one version of Python and one version of your code...
Controlled environment.
Yeah, if you can really guarantee that, like the multiprocessing module can, will actually make an exception. Pickle is safe at multiprocessing speed, just because there's no maintenance burden. Your classes aren't going to go away in the lifetime of your process. And usually. And there's no security concern. You control both ends of it. Usually there are Unix things that can happen, so that's like a thing to be aware of. But yes, in a multiprocessing-like context, Pickle was a reasonable choice there, and I wish Pickle was an implementation detail of multiprocessing and not a thing that I fight with every day.
Okay, we'll take one last question.
I've found that typically we take a similar approach of just dumping things out to an object in JSON encoding. And always start simple, but as you add more versions and deal with serializing and deserializing and subclasses and any other little tricks, it seems like we always end up inserting bugs due to trying to reinvent the wheel. Are there any libraries that you think handle a little bit more of the logic and kind of prevent you from shooting yourself in the foot there? I
don't know of any great libraries. Maybe if someone else has one, they can suggest it. If there isn't one, sorry? That's a functional definition of a database. Use SQL. One thing, sprint project for someone perhaps. I would love a way to do a lot of this logic declaratively. A lot of it is simple mappings between what the old representation was and what the new representation was. I would love a declarative format to handle a lot of the really common cases, built on top of something like JSON or MessagePack.
Thank you.
All right. Thank you all very much.
So it's now lunchtime downstairs, so I'll probably see you there. Thank you all for coming along.
Hey.